Hi everyone, so welcome to the channel. So in this video we are going to discuss the intersection of two straight lines in the topic of straight lines of junior intermediate APTS and NCERT, right? So in this video if we are going to discuss the intersection of two straight lines, right? So here the two straight lines should be non-parallel lines, right? So here what I am going to consider is I am going to consider the first line equation as L1. So I am going to represent this as A1x plus B1y plus C1 is equal to 0, and at the same time I am going to consider this second line as A2x plus B2y plus C2 is equal to 0. So these are nothing but my two straight lines, and these two straight lines, if they want to intersect, they should not be parallel. That means they should be non-parallel lines. Now let us consider this line equation as L1 and this as L2. Then there will be a point, so which is nothing but we call it as point of intersection of these two lines, right? Now this point lies on both the lines, so this point is satisfied by both the lines, by L1 as well as L2. Now in this video we are going to discuss how to find this point of intersection, right? In our 10th class, in the topic pair of linear equation in two variables, so we have learnt two methods to find out the point of intersection, right? So by using substitution method and elimination method, so you have done how to find the value of x and y from this line equation. That is nothing but the solution for these two equations. So in this video we are going to find out the point of intersection by means of the shortcut method, which we call it as cross multiplication method. So for NCERT, so it has already been introduced, whereas for AP and TS, so this particular cross multiplication method is not introduced. So this is introduced in this particular chapter, right? So cross multiplication method. So using this cross multiplication method, so we are going to find out the value of x and y, so which is being satisfied by both the line equations, so which we call it as the point of intersection of those two lines. So this cross multiplication method is also called as YCXY method. We also call it as YCXY method. So why we are calling it as cross multiplication method or YCXY method, so you will understand now, right? So here in this particular YCXY method, so we are going to start with the coefficient of y, writing from coefficient of y, and then C means constant, then x coefficient, then y coefficient again. So we are going to start with y coefficient and end with the same y coefficient. So that's why it is called as YCXY method, right? Now writing down the coefficients, so we are going to get B1, next C1, next is A1, next B1. The same way for the second equation, writing down YCXY, so those are nothing but B2, C2, A2 and B2, right? So since I am interested to find out the values of x and y, so that's why, so this particular set, so this particular B1, C1, B2, C2 set will give me the value of x. Next, this particular set gives me the value of y, and since it is constant, I am considering the constant as 1, right? And after that, so since we are calling it as cross multiplication method, so to get the values we are going to do the cross multiplication for each square. So for each square that is formed, we are going to do the cross multiplication. Now if you observe it carefully, to find out the value of x, so here x divided by, now the cross multiplied values should be written below this x, and these should be written in the form of proportion. Okay, then B1 into C2, so already you know in the concept of determinants, so we are going to find out the determinant of B1, C1, B2, C2, the second order determinant, right? So in that way, if you go B1 into C2 minus B2 into C1, so you already know how to find the determinant, right? So here we are going to find out the determinant of this particular part. The same way we will be continuing with this part and later on with this part. So x by b1 c2 minus b2 c1 is equal to here y divided by its determinant. So c1 into a2 minus c2 into a1 is equal to the same way 1 by a1 into b2 minus a2 into b1. So we got all the proportions, right? The first proportion, second proportion and third proportion. So all are proportional to each other. Now if I want to find out the value of x, so I need to make x as subject. That means if I want to find the value of x, I am going to compare this x first ratio with the last ratio. The same way, if I want to find the value of y, I need to compare the second ratio with the third ratio. So if I continue with that, then what I am going to get? I am going to get x is equal to, so this b1 c2 minus b2 c1 will be cross multiplied. Then finally what I am going to get? I am going to get x is equal to b1 into c2 minus b2 into c1 divided by a1 b2 minus a2 b1. So this is nothing but the value of x. The same way we can find out the value of y. So if you observe the value of y, what I am going to get? c1 a2 minus c2 a1 divided by the same denominator. So which gives me c1 a2 minus c2 a1 divided by a1 b2 minus a2 into b1. Now this is nothing but my x value and this is nothing but my y value. So from this clearly what I can say, since a point of intersection, no, so point of intersection means we need to represent that point of intersection in an ordered pair. So ordered pair means always x comes first then y. So what is x here? So it is nothing but b1 c2 minus b2 c1 divided by a1 into b2 minus a2 into b1. So this is nothing but my x coordinate, and next y coordinate is c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. So this is nothing but my point of intersection, which is being satisfied by both the line equations L1 and L2. By using this particular point of intersection, so we're going to find out the solution for the two straight lines which intersect. Okay, so in this way we can find out the point of intersection. So other than using the formula, so we can directly apply the values here. Then how we have done the process, the same process if you do, then also you are going to get the same thing. So there is one more representation for this point of intersection. So instead of writing this, we can represent this in terms of determinant, that is nothing but, so point, so determinant of, so this I can write as b1 c1 b2 c2, right? Then it is, its determinant value is giving me b1 into c2 minus b2 into c1 divided by, so a1 b1 a2 b2, right? So likewise also we can represent the same way c1 a1 c2 a2 determinant of by determinant of a1 b1 a2 b2, right? So using the determinants also we can represent as a point, otherwise we can represent in this particular way. So there are two types of representations for point of intersection of two non-parallel straight lines. Okay, and here one more thing, the condition that should be satisfied is nothing but a1 into b2 minus a2 into b1 should not be equal to 0. So this is the most important point that is needed to be satisfied, because the denominator a1 b2 minus a2 b1 should not become 0. So if it becomes 0, that means they becomes parallel. Okay, so this condition is nothing but parallelity condition. So if it is equal to 0, then we can say that the lines are parallel. So if lines are parallel, there won't be any point of intersection, right? So if there is no point of intersection, so there is no matter to find out the point of intersection, right? So this thing you need to keep in your mind while solving the problems, right? So this is nothing but the point of intersection b1 c2 minus b2 c1 by a1 b2 minus a2 b1, comma c1 a2 minus c2 a1 by a1 b2 minus a2 b1. Okay, next moving on to the concept of half planes. So half planes, right? So you can see this white portion, right? So this is nothing but a plane, or simply if I consider a particular part of this plane, so this is nothing but my plane, right? So in this plane, if I draw a line, in this plane if I draw a line, then this particular plane is divided into three parts. This particular plane is divided into three parts. The first part is nothing but the part which is contained by the line. So part which is contained by the line. So the part which is contained by the line, and the second part is the left side part. We can simply say the left side part. Next, the third one is the right side part. Okay, so whenever you draw a straight line on a plane, then that plane is divided into three parts. The first part is nothing but the part which is contained by the line. The second part is nothing but one side of the line, and we can say the other side of the line. Okay, so instead of saying left side part or right side part, so we can say one side, or we can say one side and the second part is the other side. Okay, right. Now using this concept, so we are going to discuss about the ratios. Okay, the ratios related to these things, right? If I consider this part, so what is that part? Part contained by the line. So whenever you consider points on this line, so whenever you consider points on this line, then what I can say, all the points lie on this line. That means all the points will satisfy the given line equation, right? So here what we can say, simply if my line is L, then it satisfies the condition L is equal to 0. So all the points which are contained in this particular portion, so they all satisfy this condition, L is greater than 0, right? Next, there is one side and the other side. So there are two more portions. So regarding these two portions, so we are going to discuss now. So in these portions, since whenever you substitute in this particular line equation, ax plus by plus c is equal to 0. So this is my line equation, ax plus by plus c is equal to 0. So when I consider L, then this equal to 0 we are not going to consider, right? Now whenever you are taking the points which are contained in this first part, so first part means which are contained by the line. That means on the line if you consider the points, then in this situation what you are going to get, the value always gives me 0. That means simply what I can say, so in this particular situation what we can say, points lie on the line L. So we say that the points lie on the line, right? So whenever you substitute the values of x and y in this particular L value, that means we are going to get a real number, right? You are going to get a real number. So this real number can be divided into three parts. Either this particular real number can be 0, or these can be negatives, or this can be positives. That means this value of ax plus by plus c can be 0, or can be negative, or can be positive. So there are only three possibilities. If you consider the points which lie on the line L, then we say that its value is always 0. That means it always satisfies this point, this condition. Next, there are two more conditions, negative and positive. That means we can simply say either L will be greater than 0 or L will be less than 0. So for which values of points, so either this part, this side, or this side, so we can't say. So for which side this L will be greater than 0 or L will be less than 0. So about that we are going to discuss in this particular half planes concept, right? Now let us move on. Now let us move on with this. See, I am going to have a line in the plane. So this is my line, L. Now for suppose I am going to consider 2 points A and B. So let us consider this point as some x1 comma y1, and let this point be some b x2 comma y2. Okay, now since we know that A and B are on the either side of the line from the figure, right? Now what I am going to do is I am going to join these 2 points. Now my ultimate goal is to find out in which ratio this line L is dividing my line segment joining AB. Okay, for that what I am going to do is I am going to consider this as some L is to M ratio. For suppose this particular line L is having some point P. So at this particular point P, this line segment joining AB is being divided in the ratio L is to M. Okay, so in our coordinate geometry, so already in our 10th classes, so we have a basic idea, right? So to find out this point of point of section, right? So by using the section formula we can find out this point P, right? So for that we are having the section formula now. So from that what I can write, P is equal to, so already we know mx2 plus nx1 by m plus n plus my2 plus ny1 by m plus n, right? So using that formula, so how can I write it as L into x2 plus m into x1 divided by L plus m comma Ly2 plus ny1 by L plus m. Okay, so this is nothing but the point in which this particular line segment joining AB is being divided in the ratio L is to M. Sorry, this is L M. Okay, so L into x2 plus m into x1 by L plus m, Ly2 plus my1 by L plus m. So this is nothing but the point P. But we know that this point P is lying on this line equation L, right? So that means this point P will be satisfying this line equation. Let us consider this line equation as ax plus by plus c is equal to 0. So this is my standard line equation, right? So this particular line is ax plus by plus c is equal to 0, and this point P is lying on this line. That means it should satisfy the given line equation. So satisfying the line equation means, so when I substitute this point P in that line equation, that means A into, so what is the value of x? So this is nothing but my x and this is my y. From that what I can write? So I can write as Lx2 plus mx1 by L plus m. So here in this my particular value what I need to find is the ratio L is to m. Now A into Lx2 plus mx1 by L plus m. Now B times of what is the value of y? So y is nothing but Ly2 plus my1 by L plus m plus c. This should be equal to 0 because it should satisfy the line equation. Now by taking the LCM as L plus m, so L plus m is nothing but my LCM, then multiplying these values, A into L into x2 plus A into m into x1 plus B into L into y2 plus Bm y1 plus C times of L plus C times of m is equal to 0. So when we cross multiply, this L plus m becomes 0. Now from this, if I take L as common among all the terms, if I take L as common, then what I am left with? So A into x2 plus B into y2 plus C plus, if I take m as common, then what I am having here? So A into x1 plus B into y1 plus C is equal to 0. Now in this I am interested to find out the ratio of L is to m. So for that what I am going to do is I am going to transpose this whole thing to right hand side. Then I can write as L into ax2 plus B times of y2 plus C is equal to minus m times of ax1 plus by1 plus C. Now since I need L is to M, I can write it as L by M. So this M I am going to transpose to left hand side. Since it is into, it becomes divided by. So L by M is equal to minus of AX1 plus BY1 plus C divided by AX2 plus BY2 plus C. Now for my convenience, since I have substituted in the place of X, X1 and in the place of Y, we are having Y1. The same way here also we are having in the place of X, X2, in the place of Y, Y2. So for my convenience, what I am going to represent this is, since L is nothing but AX plus BY plus C is equal to 0. Now since I have substituted X1, Y1, so I can see X1, Y1 in the numerator and X2, Y2 in the denominator. So I can write it as minus L11 minus L11 divided by L22. I am going to denote this particular AX1 plus BY1 plus C as L11 and AX2 plus BY2 plus C as L22 for convenience, right? So from this what I can say, the ratio, sorry, not ration, it is ratio. So ratio is nothing but, so in which ratio it is dividing, I can simply say that it is divided in the ratio of minus L11 is to L22. What is the ratio? Minus L11 is to L22. So you need to remember this formula. So if you are asked to find out the ratio, then you can simply do L11 is to L22. What is L11? So L11 means when you substitute in the place of X, X1, in the place of Y, Y1. So this type of representation notation you can have in the upcoming chapters also. So that's why you need to remember this. So where L11 means AX1 plus BY1 plus C and L22 means AX2 plus BY2 plus C. So these things you need to remember. So in this particular thing we have found the ratio. So what is the ratio? Minus L11 is to L22. Now we are going to talk about, so in the same side or the opposite side. Okay, so what is the ratio we got? Minus L11 is to L22. So what do we got here? Minus L11 is to L22. Now this particular thing we have obtained when we have considered the points on either side, right? When we got the points on either side. That means, so minus L11 is to L22. Minus L11 is to L22. So if they need to be on either side, so what we can say here? Here L11 and L22 should have the same signs. Sorry, here L11 and L22 should have. So if this becomes positive, so what is the ratio? Minus L11 is to L22. So already we know, if ratio is positive, that means what we can say? It is dividing internally. It divides internally, right? It divides internally. So if it divides internally, that means this ratio should become positive. So for this ratio to be positive, here L22 if it is positive, L11 should be negative, right? L11 should be negative. Then only negative of negative will become positive. So positive is to positive gives me positive. That means L11 and L22 should have opposite signs. So from this what I can say, if L1 and L2 have opposite signs, that means it divides internally. So if it divides internally, that means they are on either side. Okay, now I am writing here the simple wording. If L11 and L22 are having opposite signs, so what I am saying, if L11 and L22 are having opposite signs, then the points lie on either side. lie on either side of L. Okay, then automatically the other condition also you can represent here, right? So what is the other condition? If L1 and L22 are having same signs, then what we can say? Then the points are on the same side. Then the points are on the same side of L. So here very simple. What we can see, the phrase same means same side, opposite means either side. So opposite means opposite sides, same means same sides. So here what we need to find out, L11 and L22 values. So if you get those two values, then directly you can say the points are lying on either side or on the same side of the given line. Okay, so this is about the ratios and about the concept of the points, whether they are lying on the same side of the given line or either side of the given line. Okay, next moving on to the concurrent lines. So what is meant by concurrent? See, you might have heard this word congruent. So congruent is different from concurrent. So congruent means it comes with shapes. So if you are having same shape and same size, then we call it as congruent. Okay, congruent is different from concurrent. So it is concurrent. Okay, so congruent is different. So regarding this you have already learnt in your previous classes, whereas about concurrent now you are going to learn, right? So whenever you are having two lines and they are intersecting at a particular point, so this particular point is called as point of intersection. So already you have learnt, right? So concurrent lines means if you are having three or more lines, and if they are passing through the same point. Okay, now you might have understood, right? So concurrent lines means, so two or more lines which are passing through the same point of intersection is nothing but called as concurrent lines. So for concurrent lines you should have minimum 3 lines, and all those 3 lines should pass through the same point. And this particular point, so whatever the point that we have, so this particular point we call it as concurrent point. So this particular point is called as concurrent point or point of concurrency. It is called as point of concurrency. Okay, now concurrent line means, so simply what we can say, 3 or more lines passing through same point. So such points are called as concurrent. So such lines are called as concurrent lines. Okay, so to say about concurrency, to talk about concurrency, so we are going to have some particular conditions, so which we need to satisfy. Okay, so let us see those conditions. The first condition, so condition number 1. So condition to say whether the given lines are concurrent or not. So condition for concurrency. So first one is, so first of all what you do is, so find the point of intersection of any two lines. So find the point of intersection of any two lines. So take any two lines and find out the point of intersection. So already we have discussed about this, right? Then what you have to do is, then substitute point of intersection, then substitute point of intersection in third equation. If it satisfies, then they are concurrent. If it satisfies, then what we can say, then lines are concurrent. Then lines are concurrent. So the first condition is what will you do? Find the point of intersection of any two lines. So here you can consider any two lines, then substitute the point of intersection in third equation. So other than these two lines, so third equation will be no. So in the third equation, if you substitute, if it satisfies, then we say that lines are concurrent. Okay, so this is one approach by which we can say that the lines are concurrent. Next, second one is nothing but, so what is second one? Simply find out the determinant. So simply find out the determinant obtained by the coefficients of the given lines. Okay, so for suppose if I consider the lines as a1x plus b1y plus c1 is equal to 0, second line equation is a2x plus b2y plus c2 is equal to 0. For suppose if I am having a1x plus b1y plus c1 is equal to 0. Next, a2x plus b2y plus c2 is equal to 0, and the third line equation a3x plus b3y plus c3 is equal to 0. If these are the three line equations, and if you want to test that these three lines are concurrent or not, then what we need to do is consider their coefficients. So a1, b1, c1, a2, b2, c2, a3, b3, c3, and if its determinant value is equal to 0, then we can say that the lines are concurrent. If determinant is 0, then we say that the lines are concurrent. If it is not equal to 0, then those are not concurrent. So likewise we can check for concurrency. So you might get a doubt, then what is the point of concurrence? What is the point of concurrence? So what is the point of concurrence? Point of concurrence is nothing but point of intersection of 2 points only, two lines, right? So point of concurrence is nothing but point of intersection of any two of those concurrent lines. Okay, so likewise we can find out the concurrent point of concurrency of three lines, right? So using this point of concurrency concept, so we can find out the centroid of a given triangle, the circumcenter of a given triangle, the same way orthocenter, circumcenter, centroid, the same way excenter. So these all are the things that we can find out using this point of concurrency, right? So in the board examination, so you are going to get a long answer question. So based on that circumcenter or finding out the orthocenter or the centroid. So centroid is easily we can find it out. So basically, so we are going to do problems related to circumcenter and the orthocenter. Okay, so those questions will be asked so most frequently in your board examination, right? So using all these concepts, so whatever the concepts that we have discussed in this, so using these concepts, so we are going to do the problems in the exercise, right?